Hi everyone, here's to the next installment of some problems and solutions. Today we're looking at the perimeter challenge from the Cambridge Uni Enrich site. And I've got the site there, and I'll work through the perimeter challenges and some of the ways to work them and some of the key assumptions that may not be apparent, particularly from the problems that are presented on the website. So let's start with the first problem. And here we've got a small rectangle that's used to make up two towers, a little small tower, which is this one here, and a big tower, which is this one here. And one of the key things we're trying to find here, well, the key thing is we're trying to find the perimeter. So the first key assumption that's inherent in this diagram is that the rectangles are all the same, and so we're using let's call them equal or the same. So we're using these rectangles, and they are long side is L, short side is W, and the perimeter is simply going to be 2L plus 2W. Okay, so if we look at this diagram here, let's just label each of these heights and lengths. So here we've got a W, this is a W, this is an L, this is an L, we've got a W, W, L, L, W, W. So effectively, this tower is made up with two rectangles on their side, one on the bottom, one vertically, and then this one's made up of four on their side and three vertically. So if we look at the first premise and we look at the total height of the tower, so this is the total height here, let's call that H. Of the big tower, it's simply 4W plus 3L. It's equation 1. As you can see, you've got 3 L's making up the height plus 4 W's. And then if we look at the height of the little tower, let's call this H. So that equals 2W plus L. That's equation 2. Now, if we add one of the other things we know, and we know that this equals 33 centimeters and this equals 13 centimeters. That's the only two bits of information we have. But if we also look at adding another tower the same as H, so let me just dotted line draw that here. Actually, I'll use a purple color. So here we've got another tower. And that's height H as well. So let me just use the red. So this is simply 2H. And if we also look at in comparison, the difference between the two towers added together, two small towers and the big tower, that difference is simply 33 minus 2 times 13, which is 7. So it's 2 times this tower here, which is 13 centimeters. Okay, so now we have a third equation we could put together, which is H minus 2H, which is the height of the big tower minus the height of two little towers combined together. That equals H is equation 1, which is 4W plus 3L minus 2H. Let me just. Then 2H is equation 2, which is 2W plus L. 2 times 2W plus L. And that has to equal 7 centimeters. So therefore we get 4W plus plus 3L minus 4W minus 2L. Hence, these cancel out. 3L minus 2L is 1. So therefore, L equals 7 centimeters. And therefore, 2W plus 7 equals 13 centimeters, which is equation 2. We're just adding in the values. So therefore, W equals 13 minus 7 divided by 2 equals 3. And therefore, the perimeter is simply 2 times 7 plus 2 times 3, which equals 20 centimeters. So that solution was really using very little knowledge provided and the relative shapes and heights of what was provided to derive the perimeter of the little rectangles. Okay, so let's go to the next problem. Here we've got a series of rectangles in a different configuration. And all we know about them is that the area is 60 centimeters squared. Now again, there's an assumption here that the rectangles are the same. And what we've got is very similar. We've got the longer side, and the shorter side this time is the height and the width. And the perimeter is 2W plus 2H. Again, we've got to find the perimeter of the small rectangle. So what we do know is that the height, which is the total height, the big H, let's call that H, is simply in each of these little rectangles, that's a H, that's a H, that's a H, and that's a W. And these rectangles, they're just vertically, these horizontal ones vertical. So this is actually W, and that's a H, that's a H, and then we can just say that's the length. We know that the big H, total height, is simply 3H, which equals W. And that's equation 1. There's 3H, and I'll use, and there's your W. Okay. We also have 5 rectangles, and if they're the same, then the area of each rectangle, so we've got, let's call A1 equals A2 equals A3 equals A4 equals A5, and therefore 5A1 equals 60 centimeters squared. Therefore, A1 equals 60 on 5 equals 12 centimeters squared. So we have, if we take this, we can derive the second equation, which is if the area is 12 centimeters squared, we know the area of the rectangle here is simply W times H equals 12, and that's equation 2. So if we substitute equation 1 into 2, we have equation 1 is W equals 3H, so 3H times H equals 12. It gives you H squared equals 12 divided by 3 equals 4. Therefore, H equals 2. Therefore, W equals 3H, which is 6. And therefore, the perimeter is simply 2 times W plus 2 times H, and that equals 16 centimeters squared. So it's really about looking at the relative position of how the rectangles are set up and what you can derive from very little knowledge. Okay, let's go to the next problem. And this is, again, similar to work out the perimeter of this. And this time we've got more rectangles, and they're aligned slightly differently. So again, we're saying the rectangles are the same or equal, and let's use similar terminology. So longer side is W, shorter side is H, the height, and the perimeter equals 2W plus 2H. So we can see a couple of things. So firstly, let's just label the height of these rectangles. So that's a H. H, each of these little heights here for these horizontal rectangles is H. The horizontal distance for these vertical rectangles is H as well. This is W, hence this is W because it's just vertical. And then if we just kind of go the big L. Okay, so we can see firstly that W equals 4H, which is this height here is equal to 4 of these heights. So that's our equation 1. Oops, let me just change that again. Let's do that properly. Okay. And now the width, if we look at the length, so then is equal to H plus W plus H equals W plus 2H, which is equation 2, and that's simply this plus this length here. Now if we substitute equation 1 into 2, W equals 4H, so therefore equation 2 becomes 4H plus 2H which equals 6H. And that's equation 3. So therefore the total area the length equals 6H. Let me just get that length there. Okay, so now we go total area equals big W, which is big, simply the length times W based by height. That equals 6H, which is equation 3 here, times W, which is 4H, and that equals 600 millimeters squared. Therefore, H squared equals 600 on 24, which is 25. Therefore, H equals 5 millimeters, and therefore W, which is 4 times H, is 20 millimeters, and therefore the perimeter is 2 times W, which is 20, plus 2 times H, which is 5, and that equals 50 millimeters. Okay, let's go on to the next problem. This one's slightly different in that there's even less information, and again we're making the same assumption here. Rectangles are the same or equal. And again, if we take the longer side, so these rectangles, as you can see, they're made up of rectangles with a shorter and longer side on one side, and then the other one's just flipped on the other side. So let's just start with rectangular shape, and let's call the shorter side X, and Y equals the longer side. And the perimeter is just simply 2x plus 2y. Now if we look at this diagram, we take the longer side, which is y, 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 y. So the heights of these rectangles here are slightly taller than the ones on the left-hand side. So these are x. And one of the things we can see straight away, if you look at the total height, the big H, height H equals 5x, which equals 4y. And therefore we can say x equals 4/5 y, and that's your first equation. And then if you look at the total area, there are 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we say area 1 equals area 2 equals area 3 equals area 9, i.e. they're all equal, then what we can say is 9A1 equals 600 millimeters squared, i.e. the addition of all of these areas, and therefore the area of one of the rectangles is 600 on 9. Oh, hang on a sec, apologies. 180 is what we want. We've got the other problem. 180, and that equals 20, and this is centimeters, 20 centimeters squared. And so if we look at A1 is simply x times y. So that equals x times y, which is equation 2. If we substitute equation 1 into equation 2, we get 4/5 y times y equals 20. Therefore, y squared equals 5 on 4 times 20 equals 25. Y equals 5. Therefore, x equals 4/5 of 5 is 4. And therefore, the perimeter equals 2 times x, which is 2 by 4, plus 2 times y, which is 2 by 5, and that equals 18 centimeters. Now we get to our last problem. This one's about perimeters. So what we want to do, and I've added the words here, reflect the answer as a function of A, B, and C, and you'll see what I mean. If we just left this problem as find the perimeter, what you would do is just simply start with the overall perimeter has got to be, start with A, it's got to be A plus B plus all of the heights of these plus all of the widths, which are all of these. Oops. Now let me just do that again. And that's all of the heights for the areas, the jagged shapes here that we don't know, and all of the widths for the jagged shapes. And so what I'll do is I'll label the vertical ones H. I'll use a darker color. So we've got H1, and then if we just draw this line parallel here, you can see that this is C, the same as C, and underneath let's call that H2. And then we've got H3 here and H4 here. And then similarly, if we do the horizontal lengths, let's call that length 1, length 2, length 3, length 4, length 5, and length 6 just at the top there. So if we add these up now, so you've got A plus B, and then we've got all the heights. So let's add all the heights. So it's H1 plus H2 plus C plus C again plus C again. So you've got, I'll just do it in green, you've got the C here, you go up this height, and then you come down this height, and you go up this height again. Okay, and then we've got plus H3 plus H4. So that's all your heights. And then you also add all your widths, and that's simply L1 plus L2 plus L3 plus L5 plus L6. So let's start with the widths. If you look at this, this is actually, when you add these together, is simply, I'll use purple, that, and that all together, which is actually the length B. So this equals, whoops, this equals B. So now we get perimeter equals 2B, so B plus A plus H1 plus H2 C plus 3C plus H3 plus H4. So that's the widths. Now if we look at similarly the widths, you can see that actually, the heights, heights, you can see that H1, H2 and C, one of the C's adds up. So if we're slowly coming up to make the length A, we're going H1, H2, C, then we've got H3, H4. So the other two C's here we don't need. So effectively, you can rewrite this as 2B plus A plus H1 plus H2 plus C plus H3 plus H4 plus 2C. And this is simply A. And therefore, we get A plus A. The perimeter just simply becomes 2B plus 2A plus 2C, which is far simpler than the equations here. So you can simplify it quite a lot if the right pattern emerges that you can bring it down to. I hope that's been of help. That's all there is. Thank you very much.